Hello, I'm Professor John Sherlock, faculty in the DM program, and I'd like to talk briefly about data coding and software tools that assist with that coding. As a scholar practitioner, you may find yourself with a body of evidence relevant to your research question or questions that contains both quantitative and qualitative research studies or articles. So how do you best analyze and synthesize that data set in order to answer your research question? In the old days, we'd use colored highlighter markers to mark the text segments in those studies that seemed relevant to the question we were trying to answer. We would assign names or labels to describe what those segments of text represented to us. We would use different colored markers to identify the different descriptive labels. That was called coding the data back then, and it still is called that today. What's changed is that there's now data analysis software that's eliminated the need for highlighters. And it has made the coding process not only much more efficient, but also more functional in terms of helping you put together the pieces of the puzzle in your data set. Essentially, coding is a process whereby we make sense of the data in our data set as a means of answering our research question or questions. Typically, the relevant sections of articles for coding will be the results and discussion sections. You may also want to extract and code other information about the study, such as the year of the study, the research design type, sample size, and the characteristics of the sample population, as contextual variables are almost always relevant in a management study. By that I mean size and type of company, geographic location, gender, age, position of those individuals in the sample, etc. As you read and reread the articles in your dataset, pay particular attention to where studies' findings converge, i.e. are basically in agreement, where they diverge, are in conflict in some way, or are complementary. By that I mean are similar not in terms of specific findings and conclusions, but in terms of broader concepts or theory. It's a good idea to read some of the excellent textbooks and other materials detailing the many techniques for coding data. But there's no substitute, in my view, for repetitive reading and reflecting on your data, repeatedly, in a systematic manner. What you notice in your data set today may change when you reread and reflect upon it a week later. It's for this reason that I encourage students to write short memos after each coding session with an article. The good news is that most of the software programs now have this memo function built in with automatic date-time stamps. Documenting your thoughts and interpretation of the data's meaning is important for demonstrating both the rigor and transparency of your data analysis. Additionally, these memos enable you to have a conversation about your data that will prove so valuable when you're looking back at your coding and wondering, what was I thinking when I assigned those codes? There will likely be points where you feel a bit stuck in your coding analysis because the research question is not getting answered quickly or clearly as a result of your coding. One of the functions of most of the software tools out there is that they provide nice graphical interfaces, visual diagramming, so that you can see all the text segments for a coding category across multiple studies. In this regard, the software can facilitate data analysis and your identification of themes, etc., but it doesn't do the analysis for you. That's still your job. That said, one of the real benefits of the software is that it makes changing a code name or combining codes so easy. It also quickly tells you which coding category has been assigned the most across your data set, often known as frequency counts. However, don't assume the coding category that has been assigned most frequently is necessarily the most important or insightful finding in your analysis. Sometimes the code with the highest frequency count merely represents the most obvious or common element, not the most interesting. As far as which software program to use, the DM program doesn't endorse one data analysis software package over another. Instead, you'll learn in various courses about several of the more popular ones, NVivo, Atlas TI, Max QDA, to name a few. And then you can make a decision about which to try on a particular DM assignment. I say try because many of them offer free trials so that you're not fully invested in one product should you not like it. While each of the software makers no doubt believes their product is superior, I have found that the software packages are more similar than different. Sometimes small groups of students will intentionally each purchase the same software tool so that they can have each other as resources as they learn the software. All of the more popular software tools have online video tutorials and other helpful customer support services. While there's much more to be said about the process of coding one's data, I will end with a general caution against what might be called coding for the sake of coding. Not every line of a study needs to be coded or labeled in some way. Ask yourself as you consider coding a segment of text if and how this piece of text, in the way in which you plan to code it, is truly useful in helping you address your research question or questions. Hope this brief commentary on coding and data analysis software has been helpful. Thanks for watching.